Okay, with number 7, 8, the ninth and 10th terms of a geometric series are 36 and 108 respectively. Find the 7th term of the geometric series. Now, because they've given us two successive terms, the 9th term and the 10th term, we can easily work out r by dividing those terms, okay, because that gives us a common ratio, doesn't it? And in this case, it's going to be 3, right? So think about it. If I times 36 by 3, I get 108, don't I? I get the next term in the sequence. So what we can do from here then, now that we know the ratio, okay, the common ratio, we can work back then to work out what the 7th term of the series is. Now if you think about it, T9 is 36. That means T8 then will be 36 divided by that 3, which will be 12, yeah? Because if I times this by 3, I get to T9, which is 36. And then T7 then, well, I'll divide this by 3 again, I'll get back to 4. Okay, so that's what the 7th term is. Okay, so in B then, it says in another geometric series, this first term A and common ratio R, the second term of the series, so T2 is 9, and the sum to the infinity of the series is 48. So we've got to show that the equation satisfies 16r squared minus 16r plus 3. Okay, so if we use the formula here, so this will be AR, won't it? T2, which is 9. This will be then sum to infinity A over 1 minus R, which equals 48. So what I'm tempted here, call this equation 1, but here I could take that 1 minus R up in times and call that equation 2. And then I can sub in equation 2 into equation 1. So I've got 48, 1 minus R, that's what A is equal to in here, times then, yeah, because that's what A is, times then by R. So 48, 1 minus R is A, times by R, the end there, and that equals to 9. Okay, so before I expand this, it might be good to write that R at the front. So you get 48R, take away 48R squared is equal to 9. Okay, then I think we can divide by 3. So you get 16R minus 16R squared equals 3, and then get everything onto one side, you get 16r squared minus 16r plus 3 equals to 0, which is what they asked for there. Okay, fantastic. So then it says find the two possible values of r and the corresponding values for a. So we need to factorize this now. Okay, so when we factorize this, there's two options here. First we'll go through the long approach here. So we write 16r in both of them, yeah? And remember then, we've got to think of a pair of numbers. Well, because we've got 16 here and 3 here, so we're going to times them. So a pair of numbers that multiply to give 48. They've got to add up to give negative 16. So the factor pairs of 48 are here. So I'll stop when I get to a pair that works. So 3 times 16, that's no good. 4 times 12 will work, won't it? Okay, so to get them to add up to give minus 16, I need to make them both negative, and then multiply then, lovely. So negative 4, negative 12. Don't forget then you've got to divide by 16, sorry, because I times by 16 at the start. So the first bracket there becomes 4r minus 1. I'll divide that by 4, and I'll divide this bracket by 4, so 4r minus 3 equals 0. So there you go, that's factorized there. So then we've got 4r minus 1 equals 0, or 4r minus 3 equals 0. So r equal to a quarter, or r will equal to 3/4. So those are the two possible values for r. We then need to work out the possible values of a, so we sub into 1. So if you remember with 1, 1 was this, wasn't it, the first equation. So we just sub it in there. So if I put a quarter in, a times a quarter equals to 9, which implies a equals 36. or a times 3/4 equals to 9, so that means then a will equal to 12. So those are the two possible values for a there, given the two possible values for r.